What a friend we have in Jesus, all our sins and griefs to bear. What a privilege we carry, everything to God in prayer. Oh, what peace we often forfeit. Oh, what needless pain we bear, all because we do not carry everything to God in prayer. Do you believe that song you just sang? If you need help in making a decision and in staying strong, you have to decide. And when you do that, God says He'll answer your prayer. Amen? Let's pray. Father, I thank you. We admit, we confess, Lord, that we are unworthy. But you're worthy. And you've promised us, because we're your children, we can receive all things that Jesus Himself received. It's amazing, Lord. I pray your special blessing on my dear friends here this evening. Give us insight as we think about how to understand better how our bodies work and what would be best for them. And oh, Lord, I ask again on every single person, your presence and your blessing. Bless the ladies downstairs. They're preparing some samples for us. They've gone to a lot of work already, and they're going to finish it while we're speaking here. Bless them, I pray, in Jesus' name. Amen. All right, our topic this evening is on nutrition in general, particularly carbohydrate. But I'm going to finish up for a few minutes what we didn't finish last night on cancer. So instead of reviewing it, I'm just going to read to you some interesting things. Now, I spoke to you last night about soy, which people have heard makes cancer grow. I want to make sure you got this. Estrogen makes estrogen-positive tumors grow, correct? It makes them grow faster than they would have otherwise. And because soy, actually all plants, it's just that soy is higher, has some estrogen-like compounds. Some people assumed that the soy would be bad by making the cancer grow faster. Are you all with me in what I said last evening? Everybody? It turns out that there's clear research on this, that the soy actually makes the cancer grow slower. I'd like to get into the details of the receptors and how that all works. I'm not going to do that. I am going to read you 2 or 3 paragraphs that illustrate that for men and women. Now, men virtually never get estrogen-positive breast cancer. We get breast cancer, but we never get the hormone-dependent cancers that females get. But the other problem with the soy, if you remember, people think, well, because most of the soy has been genetically modified, that it would be bad for you. And I explained, let me just do 3 sentences. Because when a gene is added to a plant that did not have that gene before, you with me? So there's a new gene in the DNA of that plant, correct? Correct? That's the genetic modification. That plant now makes a protein that it did not make before. So that plant, when you eat it, has all the proteins it used to have and 1 additional protein. Got it? And there's nothing wrong with that additional protein any more than if you ate another plant that had proteins in it. And if you had a concern about that brand new protein, you need not worry, because when that protein gets into your tummy, what happens to it? Somebody tell me. Go ahead. She said it breaks down. I'm okay with that, but I'd rather have you be more specific. I've told you about 5 times what happens when protein gets into hydrochloric acid. You remember? I hear some mumbling. Who would like to mumble a little louder? Who said that? It unfolds. Proteins are always made to have a certain shape. Every one of them a different shape. You understand that? It's like as though if I was going to shake a man's hand, my hand needs to be shaped like that. But if we were going to clasp our hands like this, it would be a different shape, wouldn't it? You understand that? So every protein that your body makes, it's made in a factory first as a string of amino acids hooked up in the right order, very critical. And then it goes to another factory and it's folded up into the shape that it needs to have to make it work. Are y'all with me on that? So the fact that you get a protein that maybe wasn't in that plant before is totally a non-issue. Does that make sense? Your body just unfolds it, uses the pieces. Another interesting point along with that, in terms of protein nutrition, is that we don't eat any protein just like it is. I'm sorry, we don't use any protein just like it is from the plant, because when it gets from the plant, it has a shape, and in my tummy, it does what, everybody? It unfolds, and whatever it used to could do, it can't do anymore because it's unfolded, correct? Yeah. It's amazing how people get so mixed up. I think I told you the first night I was here that people, my wife says, now she's teasing of course, but she says, people believe you because you sound like you know what you're talking about. But isn't that the truth? Don't we tend to believe people who sound like they know what they're talking about? Sure. And there are charlatans. Do you use that word? There are charlatans who want to sell you something or sell you an idea who can train themselves to sound like they know what they're talking about. Unless you happen to have knowledge in that field and see that they are not correct, right? So, and I assured you, some of you that weren't here the first evening, these are not my ideas. This is all supported by extensive research. And I could bring in 50 physician friends that I've worked with through the years. They would all walk in here and say the same thing. And by the way, I suggested you write this down, but if you haven't, write the name of the film down I'm about to give you. You can get online and watch it for $3. You can buy it, I think, now for about $7. When I first got it, it was for sale for $10. And you can, it's on my computer now as a file, right? I just click it and it plays the video. The name of it is Eating You Alive. Kind of a cute expression, isn't it? Eat so you become alive. Eating You Alive. There's about 20 physicians, plus other experts, PhDs with nutrition and whatever, who are all saying the same thing I'm telling you. They're saying you need to eat whole plant foods without the oils. In fact, when you say whole plant foods, it means without the oils. Is that correct? Y'all with me on that? But because people don't get that, sometimes we remind them about what that means. All right, so let's read this paragraph together. I'll read it and you can follow along. The elders of Okinawa have repeatedly been shown to be the healthiest and longest lived people in the world. This was demonstrated conclusively in the renowned Okinawa Centenarian Study, a 25-year study sponsored by the Japanese Ministry of Health. The researchers conducting this study analyzed the diet and the health profiles of Okinawan elders. They concluded that, read the next three words, the high consumption of soy was one of the main reasons that Okinawans are at extremely low risk for hormone-dependent cancers, including cancers of the breast, prostate, ovaries, and colon. Isn't that remarkable? And this kind of thing, folks, is being reported by completely reputable scientific journals. Nobody can publish in those journals unless a group of scientists who have expertise on that question study it carefully and agree that it's correct. That makes sense for you? I wish you all would talk to me when I talk with you. Is it clear? Yes. All right. Compared to North Americans, now, in a way, you're not North Americans, but folks, what happens here is the very same things that happen in North America. You all with me on this? In terms of the diseases we get in our two countries. They have a staggering 80% what? Less breast cancer. It is because of the way they eat. It's not just the soy. They are plant eaters. But they identified soy as clearly one of the issues. And less than half the ovarian cancer and colon cancer. This enormously reduced cancer risk arises in part, the study authors say, from the Okinawans' large consumption of soy. The lowest cancer rates in the world are found among the Okinawans who consume the most soy. Other studies have confirmed the link between soy consumption and reduced cancer. The Japan Public Health Center found the lowest breast cancer rates in women who ate what, friends? The most soy products. Now, I would like to stop for just a second. I want you to understand something. There is no miracle food. Americans they want to look for some miracle food that if they eat that, they'll be okay. Especially if they can just keep eating everything else they shouldn't and then just eat this thing, see. There's no miracle food, in spite of the fact that soy is a good food. It's very likely that you'd get the same reduction in risk if you just ate nothing but plants, unrefined. Are y'all with me on this? It just happens that those folks use a lot of soy. And so in this country, if you ate a whole lot of mango, probably you'd get the same result. Are y'all with me on that? Okay, because it's the plants that God made, isn't it, in the Garden of Eden for people to eat. A recent study published in the British medical journal Lancet showed that women who ate the most flavonoids, mainly from soy, had a substantially lower risk of breast cancer. The next one, perhaps most tellingly, a huge study published in the Journal of National Cancer Institute in 2003 found that women with a high intake of soy reduced their risk of breast cancer by 54% compared to women with a low intake of soy. But again, folks, that would very likely happen with any plant foods that God has made. So I want to cover an area that we didn't last night in terms of genetics. I think you'll find this interesting. I think you'll find it useful. What about what to do once somebody gets cancer? It's actually true, folks, that occasionally surgery can cure. It's pretty rare because by the time you can see the tumor with an X-ray or a scan, cells have always gotten away. But once in a while, surgery can be effective. But the problem is, like I say, in a few years, cancers show up other places. Everybody hates chemo, don't they? What's the three words we say? I don't know if you do it here like they do in America. The doctors want to cut, burn, and poison. Do you use those terms? Do you? Huh? You're laughing because I guess you do. Is that correct? Oh, you've never heard that before? Oh, that's the way Americans describe what the physicians cut, that's surgery, burn, that's radiation, and poison, that's chemo. So cut, burn, and poison. Well, I want to give the physicians more credit than that, because as time has gone by and the world of radiation and even chemotherapy, which usually makes people sick, has become more and more refined, and there are cancers now where 70% of the people who take chemo for that cancer are cured. Did you get that? 30% are not. But this kind of thing, in spite of the horrible stuff that chemo usually doesn't fix, don't just throw it out with the bathwater. Are y'all with me on this? And today, there is a new form of radiation. And by the way, radiation always partially, or if you did it long enough, would completely destroy a tumor. The problem is that you hurt good tissue too. You understand that. But there is a new form of radiation. You might want to mark this down on your paper if you're taking notes. Intensity mediated is what it's called. IMRT. Intensity mediated radiation therapy. And what they've done is they've figured out how to make this part of the X-ray head have a place where the radiation comes through that has about 300-400 little fingers all the way around that can make the beam take any shape you need. You following what I'm trying to describe? You're not looking at me, some of you. It makes me wonder if you're even getting it. In other words, the fingers stop the radiation, right? So where the fingers aren't, the radiation comes out. And there's so many of them, they can finely tune the radiation to like a hair's width. You with me? So let's say there's a tumor in you somewhere, and they image this tumor, and I'd love to tell you the details, but I'm just going to tell you that they are able to make a digital three-dimensional image of the tumor. You understand what I'm trying to say? So that a computer could take that image, and wherever the beam is coming from, because the tumor is not a ball, any direction you look at that tumor, it has a different shape. Are y'all with me on that? So what they do is they lay you on a table. They actually take a couple of quick x-rays and get you adjusted so that you're within a millimeter of perfect alignment in 3 dimensions. And then this gantry, they call it, just about like a big arm that has that radiation head in it, shoots the tumor from about 10 different angles. Why would it want to do from 10 different places? To spread out the damage to the good tissue. Y'all with me? But every time it stops, the tumor's getting the full dose. You got that? And this is becoming pretty effective. There's always side effects from radiation, but it's becoming pretty effective. So those of you that, and a lot of you in this room have heard of this woman, Ellen White, who wrote, by the way, she has written more than any other woman in the history of the planet. She herself, who had a lot to say about how to live wisely, correct? Had radiation for some cancer she had. Did you know that? How many of you knew that? Let me see your hands. 1? Nice to see you. How many know it now? Please raise your hands. So you know, so you've heard that, right? So I'm not necessarily promoting those things. I'm just saying, friends, there may come times when lifestyle has reached as much as it can reach, and it might be wise for you to look at some extra treatment. Y'all with me on this? Yeah. Okay. Occasional. One of the problems is, in the cancer world, they don't keep track of you for more than 5 years, and so if you lived 5 years, you go down as being cured, even though you might die during the 6th year. Y'all with me on this? So these things can be a little deceptive. I'm not saying the medical community is trying to be deceptive, but this is an issue when people say that there was a cure. Sweetheart, do you need to interrupt me? The car key. I must have it somewhere. So we left something in the car, did we? Pardon? Oh, the cookies. Why don't we just take them home? Catch? Okay. Oh, yes. So what's happening today is, I'm going to make this real simple. You learned last night about how a killer T cell can identify a cancer and kill it, correct? So they'll take one of these immune cells out of your body and program it to identify the cancer that it has not been identifying. Y'all with me? And then they put that on a plate and let it multiply, and they try to make a few million or a few 100 million cells, and then put your own cells that have been taught to watch for the cancer back in you. So that's one of the methods called targeted immune therapy that's being developed. Natural therapies are challenging. I think it's on this slide that, and did I not tell you the story a little bit about Agatha Thrash last night? How her husband died of cancer, and how my wife and I had been encouraging people for a number of years, if they had cancer, to go to her program. Does that sound familiar? So she and I were talking over what they did for her husband before he finally passed away. Juicing, raw foods, fasting, fever treatments, hyperbaric, I mentioned this last night, different supplements. And she finally, and turmeric. You've probably heard, haven't you? I know you sometimes, some people say turmeric, and that's just fine. The real pronunciation is turmeric, but it doesn't matter. You've heard that that's supposed to be good for cancer, right? It may help. It may help in some cases. But and resveratrol, another substance that is found in plants, that when you concentrate it, maybe it helps. I think the next one tells the story. She turned to me and she says, you know, Jim, we just don't have the answer. Didn't I tell you that story last night? Yeah. So, and I think I also said to you, but I'd like you to remember this. You'll read something on the internet, or you'll hear something here or there, and somebody's just absolutely sure that this is the cure for cancer. The fact is, folks, we don't have anything yet that's even close to that. Are y'all with me on that? The biggest issue is prevention. And I went over that with you last night. So, all right. Now let's take the genetic issues. This was a magazine in America already about 12 years ago, I think. And would most of you know what that twisted ladder that's going down the middle stands for? What is that? That's the DNA, isn't it? And the reason that granddaughter looks a lot like grandma is because they don't have the same genes, but their genes are pretty close, aren't they? That's and if you read this magazine, every article in the magazine was all about genetics. And it would be a wonderful thing, frankly, if I had stored that digitally and passed it out to people like you. I think you could enjoy it. Some of it was a little deep. But here's where the genes are. I think most of you are familiar with seeing something like this. Each of those X's is a chromosome, right? Have you all seen that kind of thing? Anyway, that's where the ladder is. How many rungs in that ladder? 3,200,000,000. Does that sound familiar? Is that a lot? If that was a ladder like is in your garage, where the rungs are about that far apart, it would stretch from the earth to moon and halfway back again. So that's a long ladder. Now those rungs are actually 1,000,000 times closer than the thickness of a piece of paper. So it's pretty tiny stuff. You cannot see this with a microscope. You can see this with a microscope, just barely, because it's all wrapped and twisted and folded again and twisted again, so they can get the whole thing down to something you can see in a microscope, something that small. By the way, so let me just say, so if you want a picture, you can say, this is a ladder and that's a ladder, but actually it's a very long ladder that's been twisted and folded so it can fit. Y'all with me on the idea? Now here's an interesting point. This side comes from dad, and this side comes from mom. And every one of those DNAs from dad or DNAs from mom We all have the same number of genes with very few exceptions. And you understand that a gene is a piece of the ladder. Are y'all with me on that? So a gene is made up of a certain number of rungs, right? I'm going to actually show you a picture in a moment of a gene that's pretty interesting. And I think most of you, I'm going to find out, but I think most of you will have heard of this. So, do all of you remember, just for an example, that insulin is a protein? Y'all remember that? That means there's a gene, I'm going to use the fancy term, that codes for that protein. Y'all with me? An easier way to say it would be the gene has a pattern, so the factory can make that protein, right? I told you a story last night about where the first insulin came from for humans, aside from what our own body would normally make. Where did it come from? Somebody tell me. It came from a bacteria called E. coli. How did they get the bacteria to make human insulin? You remember? Sounds like you do. They took the human gene for insulin and stuck it in there. Got it? Okay. I'm watching your faces. I'm trying to read your faces to see if you're sufficiently amazed by what has happened. Some of your faces don't change expression, so it fools me as to what might be going on in there. So please inform your face to talk to me, all right? All right. Now, one of the genes, people have gotten in the habit of calling it the cancer gene. Has anybody ever heard of such a thing? Okay, a few of you. I'm not a moviegoer. I never had heard this woman's name before, but there's a famous actress in America. Maybe you'd know about her. Her name is Angelina Jolie. You know that? Wow, you know that name. All right. Here's the story. I hate it when people call it a cancer gene. It just makes me angry because they are so uninformed about what's going on. Let me back up one half step and remind you that all cancer, no exception, ever, is the result of usually a series, if not just a few, usually a series of mutations. In other words, on the DNA, there's a wrong rung here and there and here and there. Are y'all with me on that? A series of mutations occurs. And it happens that our body, what an amazing story, God designed some genes that when you use the gene to make the protein, are y'all with me? You get a protein of which I will show you a picture in a moment. A protein, a lifeless protein. Protein does not have a brain, is that correct? It's just a chemical that does things because of its shape. But this protein can travel along the DNA and fix the mistakes. Please be more impressed. Isn't that amazing? Only been discovered recently. Here's the problem. If that gene that codes for the repairing protein, the protein that repairs, if it's got a mutation, then the shape of the protein is going to be altered slightly or more. Y'all with me on that? Because it's going to have an amino acid in this position that's the wrong one. Y'all with me on that? So the shape will be altered slightly because of that. And what goes on with that gene is, when scientists first discovered this, they just slapped their forehead. They couldn't believe it. But we have given it a name now. It is a tumor suppressing gene, a tumor suppressor, because it goes around fixing mistakes in DNA, and all cancers are the result of mistakes in DNA. Y'all with me on this? So today, any of you here could go to a physician's office, and they could, for a very few dollars now, have your genome, that means the whole ladder, sequenced, means the order of the A's and T's and G's and C's. Y'all with me? There's 4 kinds of rungs, right? And the order of the rungs is the code, right? You could have maybe just that one gene sequenced, and they could tell you how many mutations were on that gene, and they even now have a catalog to be able to tell you what cancers might happen because that gene is encoding a protein that has a slightly bent shape somewhere. Y'all with me on that? And Angelina Jolie found out that instead of having an 11% chance of getting breast cancer, which is the average for American for females in general, different amounts in different countries, so that was in America, but they're similar. Instead of 11% chance, she had an 87% chance of getting breast cancer. On the basis of the mutations they found in that gene. Are y'all with me? And the reason they know that, they have enough examples out there of women with that particular mutation and how much of them got cancer in comparison to the rest of the population. You still following me? So they could tell her this is the chance. Not guaranteed either way, correct? But this is, so she had surgery, which is interesting. And I've always thought, since that happened, I think I would have encouraged my wife or my daughter to do the same. I'm reading a book right now which is quite remarkable. A very competent scientist is saying that if she had made lifestyle changes, she could have greater protection than she could have gotten by having the surgery. Man, you folks are unimpressed. Is that remarkable? It was remarkable to me. I thought, amazing. Now, maybe I would encourage my wife or daughter to do both. But in any case, it's not a cancer gene, folks. It's a gene that prevents cancer via a protein that fixes mistakes. Y'all with me? So the question is, how many mutations are on the gene?
Like, all the time you were there saying what?
Put the microphone.
All the time you were there saying about the genes and so on, and about the cancer gene. All that depends on the things that we consume. Isn't it?
Is that a question you're asking?
Yeah, is that all that?
No, well, the question, let me stop you for just a moment. There are several ways that mutations come. So no, that doesn't all depend on what we eat. We could eat things that cause mutations. We can smoke things that cause mutations, right? But we get some of the mutations genetically from our parents.
That was the next question.
So it depends. And everybody has known for many years that if your aunt had breast cancer and your sister and her mom did, well, her mom is your mom, whatever, there's a risk for you. We now know why. It's a genetic risk that we understand now in terms of how it happens.
Thank you very much. That was my next question.
Okay. Yeah, very good. Very good. Are y'all with me? You're clear on this issue. I'm not suggesting that everybody gets the tumor suppressor, listen to this, that everybody gets their tumor suppressor genes checked. What am I implying when I use plural? There are many of them. This was just the first one. And by the way, because the physicians thought it was connected with breast cancer, they named this gene BR for breast and CA for cancer. Y'all with me? Later on, they found another similar tumor suppressor gene So they thought that was connected with breast cancer. So they called this one BRCA1 and BRCA2. Are you all, anybody familiar with those designations? You are now. It turns out it's not just breast cancer. It's all reproductive female organs and reproductive male organs. So we need to change the name. Of course, they never will. Once you give something a name, you tend to hang on to it. So let me just give you a couple of pictures illustrating this. First of all, if we have words with the same letters in them, does the order of the letters make a difference? And I picked 2 words that only use 4 different letters. Y'all with me? To illustrate that the DNA uses only 4 different kinds of rungs, and the order would make a difference, just like it does when you read a word. Y'all with me on this? Okay. And here is, I drew this myself. I untwisted it, and I colored the rungs. This is not very important for our discussion today, but it actually happens that the rungs are made of 2 half rungs. And so there's 4 kinds of rungs. We give them a letter designation. The letter happens to be the first letter in the name of the chemical. That's the half rung. So you'll see T's and A's and G's and C's. Is that correct? And what the scientists discovered is T's are always hooked to A's, and G's are always hooked to C's. Can you see that much? And so what happens is you can have a T that gets replaced by a G, and so you have a GA. That's a mutation. Y'all with me on this? When the body makes the DNA, when you and I were one cell, that's what's supposed to happen. So a gene starts in one place and ends in another place. So I'm just saying it might start here and end there. This would be only about 20-something rungs. That's way, way, way too tiny. Most genes have thousands and thousands and thousands of rungs, but at least I'm trying to illustrate for you. The gene starts here and ends there and so forth. Y'all with me? And it codes for a protein. And this is a really interesting book. I'd love to tell you more about this man, but I just don't have time. These 400 scientists are studying this kind of thing. And let me show you a close-up of the book he's pointing to. What do you see there? Talk to me, everybody. What do you see? What letters do you see? Yes. And in fact, that book plus the ones on the shelf above him have the actual order of the rungs in the human genome. How many letters are in that set of 10 books or so? 3,200,000,000. We have peanut butter cookies tonight. I will see to it that you get an extra one. I made them. Well, actually, I helped make them. We made 96, but I ate one for lunch, so there's only 95 of them. When my wife wasn't looking, no, she gave me permission. So I love that picture because they paid $1 billion and it took them 10 years to sequence the human genome. Haven't you kind of heard about that a little bit, that was done? Sequence refers to the order of the rungs. And interestingly enough, folks, even though all of us have slight differences in our DNA is so similar, they just picked somebody out somewhere and sequenced his or her DNA, and that's what's in the books, and we all get compared to it. It's quite remarkable, even though there are differences because of mutations. Okay, so let's just quickly tell the story. I remember I was sitting in my office reading a scientific article. A female scientist reported that she found a gene in somebody, and we didn't understand then what we do now, that would cause cancer in that person. And she called it an oncogene. Y'all with me? Like the field of oncology, cancer, right? An oncogene. And everybody said, whoa, I'm glad I don't have one of those. So it turned out as they studied this thing that it wasn't active in people. Well, that's good. If the gene isn't active, it won't make a protein that will cause the cell to become a cancer cell. You understand me? Which, by the way, opens the door for lifestyle, doesn't it? To somehow maybe influence this thing. And so they call, I'm sorry about this, scientists, they think of crazy words, so they call it a proto-oncogene, which just means maybe it would become an oncogene later. And they found out that if there was a mutation, that maybe the thing would start becoming an actual oncogene, and now this person's going to get cancer. And they were surprised to find out there was another gene that kept the cell from becoming cancer after all. What kind of a gene is it called? This was the BRCA1 gene. They didn't have any idea what was going on yet. They had no idea whatsoever. They just figured out that that gene was stopping the cancer. And of course, as you now know, the way it stopped the cancer was to fix the DNA, right? Pretty cool, I think. I think you think. But this gene itself could have some mutations, as I suggested, so it might not be able to do its job, see? Y'all with me on that? Okay. So that was the BRCA gene. And later on, we had to call it number 1, and because there was going to be a number 2. How many rungs are there in this particular gene? Read the board. Amazing, wouldn't you say? 181,000 rungs. And that thing codes, I think it's the next slide, for this protein. I wish you all would say, woo. Is that amazing looking or not? Can you see where there's just a little string? That's where the amino acids are hooked tail to tail. But when it comes to these elegant shapes like a coil, hundreds of amino acids side by side, so that when this thing gets folded up, it has this amazing shape. And what does this thing do? It travels along the DNA and fixes the mistakes. Isn't that amazing? When I get to heaven, I'm going to biology class. Right? All right. I'm pretty impressed with this, folks. I hope you are too. So that's the tumor suppressor protein that your body makes. Every day your body and my body make these. And if there's too many mutations in that gene, it may not be able to repair. And this is why Angelina Jolie was at such a high risk. Now this story goes on and on. We have found actually now dozens of tumor suppressor genes. Any one of them can have different mutations, and you can go to a genetic counselor and they'll sequence all of your tumor suppressor genes if you ask, and then they will spend quite a bit of time looking up in the computer, and they'll give you, I don't know that you want to know this, they'll give you an idea of risks for certain cancers because of the mutations that you have. Y'all with me on this idea? So, however, the scientific community is kind of moving in the direction of saying, why don't we just get people to change their lifestyle? It might be better than worrying about their tumor suppressor genes. Y'all with me on this? Yeah, okay. How many amino acids in that thing? 1,800 amino acids hooked together in the right order so that the fold will keep its shape to do its job. Just an amazing story. All right. So the question then is, this is just a list on the right-hand side of some of the tumor suppressor genes that we have found. Isn't this amazing? Any one of them you can inherit mutations or get mutations. So we'll close this part by just reminding us of how you get mutations. The thing that most of you will think of right away is radiation, right? Isn't that right? Where do we get radiation from? Somebody raise their hand and give me one source of radiation. Yes. Pardon? From the sun. We get a lot of radiation from the sun. I'd love to take some time on this. I shouldn't, so I won't, I guess. But Have any of you ever heard about the fact that microwave radiation might cause cancer? Or that Wi-Fi radiation might cause cancer? If I had the time, I'd love to explain to you. I'm going to say it in a couple of sentences. We're talking about a spectrum. By the way, I don't know if I can get you to do this, but I want you to find in your hand a place where the crack between the fingers, if you squeeze it, will disappear. Find one of those. Find one of those where there is a crack. When you squeeze a bit, the crack goes away. Y'all with me on that? Now I want you to put that crack over to your eye and look up at one of those bright lights above you. Don't hold the hand away from your face. Put it right over your eye. Come on, do it. Try it. Find that crack between your fingers that when you squeeze it, it goes closed. Y'all with me? And look through that crack at a bright light. You could look at one of the side lights if that was easier. And now slowly squeeze your fingers closed. And just before the light goes out, what do you see? I don't know about that. There's a lady back there that's holding her hand away from her face. I said, put it right against your eye. Look through the crack at the light bulb. I want everybody to do this. Some of you are cupping your hand. Don't cup your hand. Pardon? No, well, I think not exactly. This is what you should see. You should see some black and white lines parallel to your fingers. Did you see that? Okay. Waves is pretty close. What that proves is light is a wave. Are y'all with me? You're not seeing waves. You're seeing the interference of waves making bright and dark lines. So there's a slight correct way to say that. Since I'm an old physics teacher, you got to say it right. Actually, you know what? As a teacher, if I can sense that the person understands and they can't say it quite right, I'm still delighted. Are y'all with me on that? And I'll encourage them to try to say it right. But I'm just thrilled that they got it. Y'all with me? Now listen carefully. These waves come in all kinds of different frequencies or wavelengths. Radio waves are the very same thing. Absolutely the same stuff. It's just that your eyes are not sensitive to the wavelengths that are longer. Y'all with me? Radio waves, TV waves, microwaves, Wi-Fi waves, clear up to infrared waves. The wavelengths that you feel warm. Have you ever driven by a big bonfire with the windows up? And what do you still feel through the window? Heat. That's infrared radiation. The same stuff as light, just a longer wavelength. No difference. Except the shorter the... Follow this, folks. I know this is a little technical, but I think people ought to know this stuff, don't you? The shorter the wavelength, the more energy is in the wave. By the way, on your AM radio dial, you know what I'm talking about? What are the numbers on the dial? 55 to 100 to 1500. Is that correct? You know what those numbers mean? 55,000 wiggles a second to 1,500,000 wiggles a second. That's how fast it's making waves. Y'all with me? What's on your FM radio dial? I don't hear it yet. It's 88 and 108. You know what that means? 88 million wiggles a second. I hope you're duly impressed. And after FM radio comes television. And microwaves and Wi-Fi and so forth. And finally, radar. Like the policeman or the airplane. Y'all with me? And finally, and by the way, the energy in the wave is increasing all that time. Y'all with me on that? Finally, you get to infrared. It's even a shorter wavelength or faster wiggles than those. Y'all with me on that? Okay? And you and I can't see that. Have you, anybody ever bought a camera, a video camera? Before we had iPhones, people bought video cameras. And there was a place, some of them you could put a switch and the camera could see infrared. Anybody ever heard of that or saw that? Yeah. And suddenly you can see in the dark, you can see stuff walking around and so forth. And then comes visible light, and then comes ultraviolet, which we also cannot see, right? And follow me carefully. There isn't enough energy in these waves to cause cancer until you get to a second part of ultraviolet. Shall I say it again? I'll tell you where I'm going with this. Microwaves do not have enough energy in them to cause cancer, in spite of the fact what the public is led to believe. Really, you ask any physicist and they'll say, of course. You understand that's my world as a physicist. You understand that? Yeah. So, because of ultraviolet light's effects, scientists have marked it into 3 categories. The first one they call ultraviolet A, which doesn't have enough energy to sunburn you or to cause cancer. You ever seen a black light demonstration where somebody has some fluorescent chalk and the lights are out and they have a funny kind of light shining on it, and when they draw with the chalk, that's ultraviolet A. Doesn't hurt you to look at it. Ultraviolet B, the next section, starting at the very edge of it. By the way, tanning beds are ultraviolet A. The problem is they're right at the edge of B, and if you stand there long enough, you can get sunburned. Y'all with me? But sunburning energy doesn't come until you're in ultraviolet B. Most of ultraviolet B is filtered out in the atmosphere, except for a little sliver down the middle, which is the exact frequency that's required. Mind you, folks, all of this stuff is the same thing you were looking at, just a different frequency. You're with me on that? Or a different wavelength. You can characterize light either by its frequency or its wavelength, okay? And I think you all know this, but if you don't, this would be fascinating to know. You get vitamin D by having the sun shine on your skin. And it is that little sliver, only that frequency of ultraviolet light will cause the cholesterol just under your skin to be turned into vitamin D. Got that? So the exposure to sunlight increases the amount of vitamin D found in your body. If your skin is dark, you need more. When I worked in Africa, and people, some of them had absolute jet black skin, some of them need 100 times as much sunlight to get enough vitamin D as a very light-skinned person. How many of you folks are aware of that? A couple, well, a dozen hands. Now, you don't have to worry around here. You get so much sunlight, it doesn't matter, right? I think it's just interesting to understand these things. Now, having said all of that, are you aware of the fact when a jet airplane comes taxiing in that there's a radar dish in that nose? Did you all know that? It shoots radar waves out there, hundreds of miles, and if there's any rain out there, some of that will be reflected back. and it paints a picture on a television screen where the water is, where the water's falling, not the water on the ground. And it's only where water's following, where water is following, that you get thunderstorms. You understand that? And the strongest airplane ever made, except for fighter jets, if it passes through a bad thunderstorm, will get torn apart. Did you know that? Yeah. So all pilots are very, very interested in staying out of thunderstorms. And you can be flying in the clouds and it's just fine. What you don't want is a thunderstorm. So they use radar. Now that's just some background. Are you aware of the fact when these big jets come taxiing in and they swing past all those people that are sitting there and park, that they, by law, they have to turn off the radar so you don't get smeared with radar? Did you know that? But you understand what I just described? Yeah. So if I'm telling you that radar doesn't hurt you, why do they tell them to do that? I'm going to tell you why, and then I'll try to get off of the technical things. You know what I'm trying to do, folks, is give you just a sense of when you listen to people say stuff and make claims, you have some grasp to say, I don't think that's right. Y'all with me on this? I think people should be educated. I'd love to spend many nights with you. You'd probably quit coming. Here's what's going on. Imagine a little tiny flashlight. In fact, this is a little tiny flashlight. I won't point it at your eye, but look at him. Look at his, well, look up here. Y'all with me? So let's say that laser was dim enough so I could shine it right in your eye and it would be okay. Y'all with me? Now imagine if there were 20,000 of those lasers in a big square here, all pointed in the same direction, and you were standing back there looking at it, you could hardly open your eyes. Are y'all with me? Now listen carefully. This may sound strange to you, but the energy in the wave has not changed. It's the word that we use is intensity. By the way, when the soldiers threw Shadrach, Meshach, and Abednego in the fire, did the soldiers get burned by the fire? The answer is no. The fire was being sucked up. What killed them? Infrared radiation, which doesn't have enough energy to cause cancer. But any radiation, if you get enough sources of it piled side by side, could be so bright that it could cause damage. Y'all with me on that? And inside the microwave, there is enough intensity to heat the food. Y'all with me? But it's carefully designed to not let hardly any leak out. You can buy a thing about that size online for a few dollars to measure how much energy is coming out of the microwave. Very, very, very tiny intensity. So I'm not pushing the use of the microwave, but I'll tell you what, it saves my wife a lot of time. Pop something in there, right? And I'm not saying you should use it. I want you to know that it won't hurt anything if you do. There is one exception, for a different reason. I think all of you women, and probably the men, also know, didn't we talk about this? That in mother's milk there are immunoglobulins. Have I mentioned that? Not very many people are nodding. Are you telling me back there that I did mention it? Okay. The immunoglobulin is a protein which provides immunity for the baby from various kinds of infections, especially, upper respiratory infections. But it's a protein, so what would normally happen in the baby's tummy? The protein would be unfolded. Could it do its job anymore? Say no, because proteins work because of their... All right. So the Creator designed the milk-producing system to put a layer of fat around the immunoglobulin, which protects it from the hydrochloric acid. Got that? So, here's the problem. I don't know if I told you this, but okay, this is a complete side trip, but I love it. He said, with everything you have described here, and I'm going to help you, the unbelievable complexity and obvious design, right? He said, are any of those scientists unbelievers? What do you think? Most of them are. Now, you didn't ask for this. I'm going to tell you. I'm going to tell you why I think they are. If you agree that there is such a thing as a creator, a designer, whatever you want to call him or her, if you're a moral person, you have responsibility to that designer, don't you? Sure. They'll never admit this, folks, but that's the real problem. You all with me? So where was I before you interrupted me with that wonderful question? The immunoglobulin, I don't think I told you this. There's something else that causes protein to be unfolded besides hydrochloric acid. Could anybody in this room tell me what that is? Did you say something? Radiation is close. The answer is heat. Let me give you an example. When you used to fry an egg, you don't do that anymore, correct? And you crack it open and put it on the frying pan. We call it egg white. It's funny because it's actually egg clear. But under the influence of heat, the egg white becomes, I'm sorry, because, listen, because the protein in the egg clear was denatured. Just an example of one place where heat denatures protein, okay? In fact, when people want a tender steak, it means you cook it in such a way that you denature some of the stiff proteins in there. Y'all with me? Another thing that you never do again, right? So, in mother's milk, then, are these proteins that if a mother chooses not to or cannot nurse the baby and then chooses to express the milk, to pump the milk, then and keeps it in the refrigerator, then she wants to warm it up before the baby gets the milk. And what happens is, when you warm the milk up, you denature some of the immunoglobulins. And scientists have tested this in microwaves. Don't go ahead of me now. You're all talking to each other about warming up milk. So please stop and listen. Scientists have learned that in the microwave, 75%, if you bring that milk up to body temperature, which is what we do, right? The temperature that the baby would be used to it at. When you bring that milk up to body temperature, 75% of the immunoglobulins are denatured. Interestingly enough, even if you heat that milk in a little pot with water on top of a flame, about 25% of the immunoglobulins are denatured. So mothers today, I think many of you women will know this, if they're going to pump, are taught to massage the milk under a stream of warm water. How many ladies are aware of that? Can I see your hands? Whoa. How many ladies are now aware of it? Ladies, please all raise your hands. Are y'all with me? So that's something we ought to know, isn't it? For the sake of our babies, if we choose not to nurse them. Maybe you guys are such good nursers, you'd never do that anyway. So, okay. So let's leave this topic. And radiation, viruses, I put toxins up there like cigarette smoke, alcohol, free radicals like, listen folks, I don't know if you caught this, the oil, when it's exposed to air and gets oxidized, those are free radicals. Are y'all with me on this? What do they do to DNA? They don't destroy it. Don't use that word. They cause mutations, which is always the pathway, folks, that brings cancer. Are y'all with me on this? And there's copy error. Do you remember that? Every time a cell copies itself? And by the way, just for the last thing before I jump into the other section on nutrition, in the human population of the world, we know of 1,900 different mutations that can be found in the BRCA1 gene alone. Nobody has all of them. But when you study every human being on the face of the earth, of course they haven't done that, but they think they got enough. There's a lot of mutations in the germline. Are y'all with me? Things are going downhill, right? And the Lord says He's going to come and put an end, right? And the sooner the better, except that I have a couple of daughters that have turned away from God. Anybody else in here like that with some sons or daughters? So I say my prayer to the Lord is, Lord, come soon, but please wait a little while for Kathy and Kimberly. I'm not joking, folks. I'm just saying. Yeah. Okay. So that's enough about this, I think. Let's go to inflammation causes cancer. All these inflammatory foods, folks, that we eat. Bad news. Okay. Let's talk about nutrition for our remaining few minutes. These are the only sources of calories. Is that correct? Correct? Yes. And fat has about how many times more than the other two? Over twice. Doesn't that sound familiar, folks, please? Twice as many calories per gram or per pound or whatever. Doesn't that sound familiar? Why couldn't you remember twice? All right. Did they say 2.5? Another cookie. Who said that? Extra cookie. Okay. Now here's some nutrients that don't provide calories. Water is actually a nutrient. If you have a textbook on nutrition, there'll be a whole chapter on water, how it works and why it's needed and so forth. And then there's these things called phytochemicals. Enzymes are not nutrients exactly, but I might get a chance to say a word about them before we're done this evening. Our topic is essentially going to be on carbohydrate, but I'm going to take a couple of minutes on these first. There was a scientist who made a bath about this big, about so deep. That's what I'm picturing. And he put little tables here and there, and he made the water opaque so you couldn't see. And he would put a mouse in the corner, and the mouse would swim frantically to save its life until it ran into a table. And it actually was a rat. To you and me, it looked like a mouse. And every day, he did this to many, many rats. Put them in the corner, and he actually found that they learned where the tables were, and they would swim right to the table. So rats can learn, right? Anybody would have guessed that. Then he irradiated their brains with nuclear radiation. That's way up here, past ultraviolet A, B, and C, up in the X-ray, and even farther than that. Very high energy particles, and it killed brain cells, and when he put them in the water, they couldn't remember where the tables were. So they had some neurological damage from the radiation, right? Now, the reason he did all of this, there was anecdotal evidence. What does that mean? What's an anecdote? A story. This is the word that scientists use to say somebody believes something, but it's just a story. But let's check and see if it's true, or maybe, you know. So there was anecdotal evidence that the brains could be repaired, for people even. Nobody had studied it. Nobody had done an experiment. You gotta be, you know, you can't just take people and irradiate their brains and see if they get better. You can't do that. It's not ethical. Now you can get away with it with rats if you're kind of half kind. Some people don't even like you to do it to rats. So he started feeding them different foods to see which food would help their brains get repaired so they could remember where the tables were. Got it? Does anybody know what brain food he found, if you want to call it that, that was the very best for the brain? Does anybody know? Coconut? What did you say? You also said coconut. Anybody know? The answer is, every American knows this. I don't know why. I mean, everywhere I go and ask that question, everybody says blueberries, because because Americans have all heard that this is just the steps that I just described. Americans have all heard that blueberries are good for your brain. Have any of you heard that now that I mention it?
No, we're not familiar with blueberries. No.
Yeah, you don't raise them. Okay.
I heard nutmeg.
Yeah.
I don't know.
You can buy them, but they're very expensive, right? You can't. Okay. So all Americans are very big into making sure they get blueberries every day. And so I often ask groups of people, would it be fair to say, if I can get you to quit talking about blueberries, would it be fair to say that we should have some blueberries every day? And the Americans will all say, yes, yes. And I say, no, no. Because Dr. Joseph, it's his name, Jim Joseph, he found out that blackberries were just about as good as blueberries. So then I asked the congregation, at least we should have some blueberries or blackberries every day, right? And they'll all say yes, and I'll say wrong, because he found out that strawberries were just about as good as blackberries. Now you know about strawberries, don't you? Don't they grow strawberries here? Yeah. Okay, you guys, please stop. I'm trying to get done on time so you can go eat cookies. Actually, what I'm trying to illustrate here, folks, believe it or not, I would like to have you own this idea. There is no particular food that you have to make sure you get. As long as you eat plants. And you could say probably it would be good to have a variety. There's actually studies that show that certain indigenous people in South America get 97% of their calories from one plant, and they're in perfect health. In other words, whatever plants you have that are available to you, that's really all you need to worry about. You all with me on that? I'm sure that blueberries and other berries help the brain, but so do the rest of the plants. So don't be over-exercised if there's something that's so expensive you just can't afford it. Get what you can afford. And yes, please. Go ahead and stand up. If they don't get a mic there, just talk real loud.
Excuse me, sir. We've been hearing in the Caribbean about kale as a superfood. I want your opinion on kale.
There's a word there that starts with K I'm not getting.
Kale.
Oh,
Kale.
kale. Is kale a superfood? Let's not do a study. Let's just take a vote. Won't that determine it? How many think kale's a superfood? Let me see your hands. How many think it doesn't matter? Let me see your hands. That group wins, even though you didn't have the most hands. Did you get my point, folks? Kale's a wonderful food. So is every plant. Y'all with me? And boy, once you guys get going, it's sure hard to stop you. Now let's go to carbohydrate nutrition. In closing, I'm going to pass up. Here's the point. There is no miracle food, folks. I'm trying to say there's no one food you just have to have, or that will cure this or cure that. That doesn't exist. Just eat what God makes available and you'll probably do very, very well. All plant food taken together, if you wish, is miraculous because it keeps us healthy. Now here is then the question of carbohydrate. It's a pretty simple plan. Let me just give you a few little tidbits on this nutrient. We call it carbohydrate because there's carbon and hydrogen and oxygen in it. And the simplest carbohydrate, I think you all know this, is sugar. Most of the sugars you find in plants have 6 sides to them, just like that. Sometimes they'll have 5. That's like probably 99% of the sugar. Probably 90% of it has 6 sides, and a few percent will have 5 sides. Some of the 6-sided turn to 5 sides back and forth, actually. And this little sugar is found just like that in plants. Not just in cane, but all plants have quite a bit of carbohydrate in them. In fact, except for the 4 categories that are high in fat, that's mostly what the plants have is carbohydrate. They have a little protein, but mostly carbohydrate. And that thing is tiny enough, when you chew it up in that apple or that piece of celery or whatever, it's tiny enough to get right into your bloodstream through the wall of the small intestine. A lot of the sugar, and by the way, you're familiar with these words, aren't you? Glucose, fructose, maltose. Those are names for single sugars. Y'all with me? You know those words. A lot of the sugar in plants, not all of it by any means, and not even the most of it, but in cane, a lot of it, and all plants have this, the sugars will come in pairs. And you know the words, some of the words that are used. You've heard of sucrose, of course. By the way, sucrose is what we normally have as table sugar. And I'll show you in a minute more about that. But most of the starch or the carbohydrate in plants comes as long chains. Are you all with me? So in the small intestine, this is too big, and this is surely too big to be absorbed through the wall into the bloodstream. You all with me on that? So it has to be cut up. What do we call that process of cutting those things up? Digestion. And this is sometimes called complex or poly. The word saccharide is a fancy word for sugar, so when there's lots of them hooked together, it's called a polysaccharide. Okay? You'll hear the word, you'll see that word some places. So there's an enzyme which comes along and cuts every other connection. Like here, here, there, and there, and there. Y'all with me on that? Pardon me? Cuts them in twos, interestingly enough. But the twos are still too big. Y'all with me? So there's a different enzyme, actually in a different place, that cuts them one more time. So they're a string of single sugars which can be quickly absorbed into your bloodstream. Now, there's another kind of starch. And I can't make Keynote or PowerPoint, if you will, do what I want it to do. I want it to just flip that sugar over. I was giving this lecture one time, and a 10-year-old boy raised his hand and said, "Would you like me to write you a program that would do that?" this little computer expert boy. So imagine now, watch me when I press the button. I'm pretending that it flipped over. Are y'all with me? Everybody? Now I need some help. Oh, can I use that thermos bottle for a second, please? Yeah, thank you. All right. That's pretty heavy. I might drop it. Is yours heavy too? Okay. Maybe. What am I going to use? Here's an example. Can I use your hat, sir? For a minute? Okay. Let's suppose this is one sugar. And let's suppose this is another sugar that's hooked to it. And in order for me to digest this sugar so I can absorb it, y'all with me? I have to cut that. And would you hold that for me right up there in midair? So there's a protein that's designed to fit in there and break that. We call it an enzyme. You know the word, enzyme. And it can't do it unless it has exactly the right shape. Y'all with me? If this one got turned over, would you agree that the shape is now different here? The other way, this was tipped that way, and now it's tipped this way. Y'all with me? So the enzyme that was designed to cut this apart can't do it. Proteins work because of their, and the shape isn't right. It was right, but it isn't right. Y'all with me on this? Thank you. We don't have any enzymes that can cut that bottom one up when it occurs like this in the food. Y'all with me? Everybody? So that's, is it starch? Yes, it's sugar. But it's undigestible. And we have a name for it. You'll laugh at this in case you didn't know it. That's what we call fiber. Fiber. It is undigestible starch. If you were in a college nutrition class and the professor gave you a quiz and one of the questions was, define fiber, and you wrote down undigestible starch, you get 100% on that question. Y'all with me on this? Now the creator put that in there because when that fiber gets in the small intestine, it absorbs water and makes a gelatinous slurry in the small intestine. I'm not sure what other word to use. Do you know what I mean by gelatinous? Kind of like jelly. Not hard, but I wouldn't want to say slime. You could say slime if you wanted. I'd rather say gelatinous. The point is this. When you have that gelatinous slurry, the food is absorbed slowly. The sugars, the proteins, and the fats, it's mechanical. It just takes time for them to pass through the gelatinous stuff to get to the edge of the small intestine and get absorbed. Got it? Aren't you happy you know this stuff? Here's the point. The Creator designed that our meal would be absorbed slowly over perhaps 6 hours. But we eat these refined foods. Would you do this for me with a second? I know this is kindergarten. Put your index finger and thumb together. Come on, you guys, everybody do it. And then draw your fingers towards your hand like that. That's how much fiber there is in all animal products. How much is that? 0. Do you think God ever intended for us to eat animal products? No. Did anybody listen to That Makes Me Mad this morning at 9? Did you hear Andre ask me when I said that really what we're teaching is the Garden of Eden diet? Correct? I don't know if you know this. Andre used to be a member of the Church of God Seventh Day. Yeah. When the church split, he kind of went with the liberals. No more tithe paying, and, the Sabbath is gone and all of that. Don't misunderstand me. I love this man. He's one of the finest, and I've been on radio programs all over the country, in the U.S. and a few overseas. He's one of the finest hosts I have ever heard or worked with. He's just outstanding. He's a lot of fun to be with. But if you listened, he challenged me with the idea that God told the Israelites to eat meat, didn't he? And Jesus ate meat. And so, well, fish is meat. By the way, as far as the Bible is concerned, there is only one time that it says that Jesus ate a little bit of fish. Are you aware of that? That's when the disciples were there and they thought it was a spirit, and he said, I'm not a spirit. Is there something to eat? I'm sorry?
Just to illustrate.
Yeah, the Bible, he says, just to illustrate. And my answer to Andre was this, folks, and you ought to use this answer if somebody presents the question. First of all, God never gave permission for anybody to use animal products except for mother's milk until after the flood. Is that correct? And there were two reasons for that. The Bible doesn't say the second reason. In fact, it doesn't say the first one. It's just obvious. When they got out of the ark, there was nothing growing. Well, I shouldn't say that. The bird came back with an olive leaf, didn't it? But probably no olives yet, right? Or much else. So there was nothing to eat. Now, I don't know. Maybe God hadn't put enough food in the ark, but there was plenty to eat. My point with Andre mainly was that the lifespan, when God gave them permission to eat only clean meat, right? Because only two of the unclean went in, and if you killed one of them, that's the end of it, right? When God gave mankind permission to eat animal products, or flesh, if you will, the lifespan decreased from about 900 years to 175 years in only 10 generations. And we're quite certain it was the high protein and maybe other poisons, folks, that are in animal products. So, fiber. Let me give one more illustration. Imagine being in a swimming pool. You don't have swimming pools. Imagine being in the ocean. And the ocean is made of molasses. I know you have pools. I was teasing you. So you're in a pool and it's molasses. And, well, let's say it's water, and the lifeguard blows the whistle and you swim over or walk over and climb out. But if it was molasses, it would take quite a bit of effort to get to the edge of the pool and climb out. Is that correct? That illustrates fiber. It takes the food time to get through the slurry to be absorbed. Y'all with me? So when people eat a whole plant regimen, which always has fiber, it's only animal products that have no fiber. Every plant, there is no exception, has fiber. When you eat a whole plant regimen, you don't get hungry right away, because those nutrients are delivered slowly to the bloodstream for probably, depending on how big the meal was, for probably 6 hours. So God intended for us to have a good meal, and then, this isn't a great big point. Nobody has measured this to my knowledge, but I was taught when I was a child, and we taught our girls, that we should not be eating stuff between meals. Don't most of you believe that, even if you don't do it? we have pretty good indication that it's wise to have a meal and then do not snack. Now, we do know this from science. When you've had a meal, small or large, and about an hour later or 2 or 3 before that meal is fully digested, if you have a snack, it slows the digestion process because the stomach, in a certain sense, chemically backs up to try to bring that last thing up to where the rest was. So it delays emptying in the stomach and also the digestion process, which turns out to be a problem. I don't think it's a huge problem. May I repeat myself, folks? I would like you to make these changes, but I want you to be patient with yourself and maybe not try to do everything at once. Y'all with me on this? Especially be patient with other people, right? And don't criticize other people if they're not doing what they're supposed to, right? Please say yes. Instead, draw close to them and help them, right? I think it's a good idea not to eat between meals, but I would be very happy if you ate only plant products, even if you had a little something once in a while between meals, even though I think it's not the best. He has a question. I'm sorry, here's one here. You want to give him a microphone? Okay. Go ahead.
I get it that the radiation in the microwave is not strong enough to harm us. But what about the nutrients in the food? Doesn't the microwave destroy the nutrients?
Good question, and I'm sorry when I was dealing with it I didn't mention that. The answer is no. All that you're doing with the microwave is heating the food. I'd love to tell you from a physics standpoint how that happens, but I think people would go to sleep, and I'm not sure it's all that edifying. And the reason I'd like you to tell you that, so that you would be convinced that it's not a problem to heat the food with radiation. Y'all with me on that? It's very much like heating your cheek when you drive by the fire with the window closed. In fact, that radiation is more potent than the radiation in the microwave. Are y'all with me on that? That infrared radiation is way up the scale in terms of energy in the wave, right? In comparison to the microwave. Now, we always have to think about intensity, and too much intensity of anything can harm something, see. But no, the microwaves, it's a very good question you've raised. The only problem that has ever been found is denaturing immunoglobulins. Y'all with me? In fact, do the immunoglobulins get denatured in the pot over the fire? Yes. Yes.
Is there any harm in using crystallized sugar? Like, you get the sugar cane, you crystallize it, going through the heating process, as opposed to just eating an apple or a mango or sugar cane?
It doesn't matter what form the sugar's in. It ends up in your tummy and digested in the same way. Now, folks, you all understand this. Let's just make sure that we're not misunderstanding. Sugar is a refined product, is that correct? By the way, the Creator puts a lot of it in plants. And when your people were raising cane sugar in the past, did you never break a piece off and let your child chew it for a few hours? If the child ate the whole cane, they would never get too much sugar. Of course, they don't really eat it, they just suck on it, right? My point is this. God designed, folks, that our food tastes wonderful. Amen? And if something is a little sour and you use a little sugar to make it palatable, there's no evidence that that's a problem. Now, the reason that's the case is this, folks. If you get all the vitamins and minerals and phytochemicals, sorry, it just reminds me I didn't finish the story. I'm going to stop right there and finish the story. What Dr. Joseph found was fixing the brains of the rats were phytochemicals in the food. I mentioned this the other night. I didn't stop to say much about it. Didn't I tell you the story of the trainload of garlic? What did that scientist find in garlic that nobody knew about before? 300 substances that were not vitamins, minerals, protein, fat, and carbohydrate. Are y'all with me on that? 300 brand new substances that nobody had ever looked at before. It blew everybody away. There's a bunch of stuff in there we didn't even know about. Actually, we now know there's over 10,000 different substances found in plants. And the reason they're called phytochemicals is because they're only found in plants. And we need them. And one of the studies was Jim Joseph and the mouse finding the table. It was the phytochemicals especially that he found was fixing their brains. Got that? So when you get in a meal all the vitamins, minerals, protein, carbohydrate, fat, and the thousands of different, now not any one plant has all 10,000, but any plant has over 1,000, lots and lots of them. When you get all of that, folks, and a bunch of it is sugar, is that correct? Say yes. The carbohydrate in there is sugar. If you add a little sugar, even terribly refined sugar, it's not bad. Y'all with me? Because it's just a little bit more of what God put in there to make it tasty. Huh? Could you overdo it? Yeah. So be a little careful.
I've heard that the simple sugars, right, are absorbed faster into the system than complex.
Did you hear his question? The answer is yes and no. And it doesn't matter. When the fiber is there in the small intestine, everything is absorbed over time, so the sugar never spikes. Got it? You got that? It's a non-issue. Now, if I just drank sugar water called pop, raise your right hand and repeat after me. Quit using pop. And you don't eat it with a meal, you'd get some sugar absorbed. And frankly, folks, not a great big problem, but it's a pretty strong dose of sugar. And when the level of blood sugar goes too high too quickly, your immune system is compromised. So God designed that we get our food with fiber, so the sugar, which he put in there because it tastes so good, is absorbed slowly into the bloodstream. Got that, folks? An interesting question. Thank you for that. Okay. Okay. Did I understand you to say, since I don't seem to be knocking sugar too much? Is that what he said? Please don't ever say that I said that. Too much sugar is a problem. A little sugar, folks, if you're getting a whole plant regimen, right, to make the thing palatable, is just what God normally does when the food is ripe. Is that right? Isn't that what makes something so delicious when it's ripe? Right? Sure. And in fact, all of the starch, folks, becomes sugar in your bloodstream. But when it comes with all the vitamins and minerals and fiber and phytochemicals, it's perfect. In fact, did I tell you that sugar is perfect fuel for the cells? Because when you burn it, you get water and carbon dioxide and energy, right? Perfect fuel. God designed us to run on sugar, but he wants us to get it in a whole plant form. All right. You guys all deserve a cookie tonight. Oh, the honey. He was. And by the way, it doesn't matter what kind of plant source of sweetening you use, whether it's honey or whether it's agave nectar or anything like that. It's high in carbohydrate. and a lot of the carbohydrates are single sugars, so you taste it as sweetness, or even double sugars, so you taste it like sucrose, right? And honey is actually about 50% sweeter than sucrose. You actually can use less. Fructose is the reason for that. Fructose is sweeter than sucrose, and so you can use a little less actual total sugar by using honey. Yeah, good comments and questions.
One more thing. You said that the starches, right? Like how it is at the bottom.
Yes.
The fiber with the sugar with it. It releases the sugar slowly, right?
Go ahead.
You said that the starches release the whole food releases it slowly. You also said that having snacks in between could hinder the absorption rate. So what's the difference there?
I said that what happens with a snack is that it delays the stomach emptying time. No. So I don't think we should snack. I'm just saying, folks, if a little snacking will get you through and help you stay on the program, don't beat yourself up because you had a snack. Are y'all with me on that? Be a good idea not to, or to quit snacking, so forth. A couple more pictures and then we'll go see Neva. I'm going to pass this up. I'd love to talk about it, but I want to show you. Here is the standard St. Lucian or American. They have a questionable breakfast. I don't know what your questionable breakfasts are like. Maybe you don't do that so much. But in America, people have a cup of coffee and a donut or something. Do they do stuff like that here? Well, good. What do they do that's bad here for breakfast? What? Oh, they don't have breakfast. Anyway, a lousy breakfast, please. A lousy breakfast is something without fiber and some starch or sugar or something. And what happens is the blood sugar. Did you ever see a breakfast like that? I saw some people on the ferry just eating pastry for breakfast. That's what I'm talking about. I didn't leave that on there very long because I didn't want to tempt you. Here's what happens to the blood sugar because it's low fiber and high in sugar and carbohydrate. The blood sugar goes way up quickly. The body was never designed for this. It's an emergency. It pours out insulin to try to control the sugar. And because that donut or that pastry I saw the people eating on the ferry doesn't last very long, the sugar plunges down below normal. And the people, they've learned, they have this funny feeling about them. They know exactly what will fix it. Something like that. Are y'all with me? I know you never do that, but some people do, right? And that happens again. And most Americans and many of your people live like that. Cup of coffee, donut, pastry, whatever. Y'all with me on this? So when you use fiber, of course, that doesn't happen. Fiber is something like a sponge. You know, if this muslin separated outside the body, this is just a thought experiment from inside the body. So I'm going to pour some food in the body. If I poured some kind of juice, how quickly would it get into the body? You just kind of get in there quickly. This is one reason, folks, why drinking a lot of juice is not a good idea. It's a refined product, isn't it? It would be better to eat an apple than drink apple juice, and so forth. By the way, I love your grapefruits around here. Do you guys like the grapefruits? I could eat 10 of those for breakfast. They're just fabulous. We had 2 this morning. Boy, it was good. Better than what we grow in the States. But if you put a sponge there and poured on the sponge, what would happen now? So fiber is like a sponge in helping the nutrients be delivered evenly and slowly over time. Anybody in this country ever complain of something called hypoglycemia? Okay. The answer is unrefined plant foods. Every physician friend of mine, every one of them, when somebody comes into their clinic with hypoglycemia, that's the answer. Eat whole plant foods and don't eat between meals. Okay, I think we've done enough. I was going to tell you more about fiber, but Neva is longing for you to come down and eat up those peanut butter cookies. So I think the group is so large tonight, brother. Why don't you take care of it?
Okay. We also want to thank Mr. Timothy Mangal for his generous contribution, generous donation. Ayaka Bookstore and the managers Esther Isidore and the team for collaborating with us. We also want to thank Gamma Learning Institute and my good friend Mr. Gilbert Jafaswa. He's always giving me work to do, and that one was very good work. So I want to thank them immensely. If I left out anyone, I want to thank every one of you for coming to the program and for everyone who contributed in one way or the other. Thank you so very much. And last, but by no means least, I'd like to invite Brother Pastor Brackett and his wife to please stand. Where's Wendy? Wendy, did you go? Can somebody call Wendy for me? Tell Wendy come quickly. And we want to thank them for coming to St. Lucia for almost the 20th time. And they are now officially adopted as St. Lucians. Okay? By the next time they come, they will be able to speak Creole. They'll be able to speak it and understand it. I just want to invite any two individuals who really enjoy the program. Any two individuals who really enjoy the program to please come forward. Any two individuals. My sister here who got the gift. If you got a gift, come. You got a gift, so you come. You are coming anyway. God bless you. And one other person, can you please come? Any other person? The gentleman at the back who almost got the gift, with your hand to the wall, come. You almost got the gift. Oh, your friend, okay. I want to present tokens of our appreciation to the brackets. And we know that it is a piece of St. Lucia that we are giving you. So when you go, you will enjoy, you remember St. Lucia and you long to come back. Amen? So when you handle it, tell them, give it to her. And you do it the St. Lucia way. Whatever that is.
Bracket, nous avons ça, nous avons apprécié ou pile, et nous pouvons cultiver encore des révélations.
Okay, what she said is she'd like to thank you for coming and appreciate what you did for us, and she hopes that you will come back again some other time. Well, Mrs. Brackett, on behalf of the SD Church and all the persons who participated, we'd like to thank you very much for giving us all your expertise and helping us so we can better our lives. Thank you very much. We appreciate it. It's just a small token of appreciation. Thank you very much. Oh, we have one more.
We'd like you to take this one back to your daughter and tell her thanks for us.
Now, it's strange that I came up here and I was asked to speak, but I was just speaking to my friend in the back and I was telling her that I started on my own to do some things to increase my longevity in life. And my sister-in-law invited me to the program, and I am very grateful for the program because it has opened my mind to a lot more than I had anticipated. So, from a personal standpoint, I'd like to say thank you.
Okay, if there is anybody from the Ministry of Agriculture, they might need some help to take back some turmeric. Last night she said how she enjoyed the fresh turmeric, and I brought her some earlier. She has it downstairs already. Okay, so if they have any problems, please somebody help them through the Ministry of Agriculture.
Got to be worked out. So if you really enjoy the seminar, put your hands quickly for God, and then for God using Pastor Brackett and his family to really bless us for these few days. Now we're going to go downstairs. It will be streamed up here. So as many of you who can go downstairs, feel free to go to be part of the demonstration and the sampling. And those of you who have to stay up there, if you want to stay up there, you can stay. If when you go downstairs you don't feel comfortable, you can come back up here. Okay? So we can transition to the downstairs at this time.
So can you all hear me all right? Just checking. I know that this mic here is not a PA mic. Is that correct? This is for the internet. So I think I have to wait for them to bring the handheld. Thank you. So tonight is our last time together, and so most of what you've tasted we've demonstrated. Last night I demonstrated the pudding, lemon cream pie filling, and we've made it into a pudding. You want me to put some in the pudding? This is good. So, are you able to hear me now? This is better, isn't it? I think I should make sure we have everybody's attention here. I know there's a lot going on, but it seems like there's a lot going on in the room. Maybe I'll step up here and just get a little closer for the few words that I wanted to speak to start with. We've just had such a really wonderful time here with you, and wanted to send you off with a little treat. This is two of the desserts. I showed you last night the lemon cream pie recipe in the cookbook, and that's what this is, only we didn't make it quite as thick as pie, so that it's more like a pudding. And it's made with pineapple juice, orange juice, and lemon juice, thickened with cornstarch, and then we added some mangoes to it, blended in. So it has a very nice flavor. And then instead of the pie crust underneath, I cooked the pie crust on a cookie sheet, kind of crumbled it up a little bit, and we just sprinkled that on the top. And this cookie right here, I think of all the cookies, of all the desserts in the cookbook, this is the one that I make the most. Some of you are nodding. Do you make that one? How many of you have made that peanut butter cookie recipe that have the cookbook? Wow, you're the champion tonight. I've learned to make cookies because I have a husband who loves cookies. And he loves to have just a little something at the end of the meal to maybe stimulate his enjoyment part of the brain. So I've heard that, so psychologically that's good. You know, God has given us the sense of taste, and he wants us to enjoy our food, and I'm sure that one of the ways he's done that is to make things that are sweet. And of course, not everybody loves sweet. I have a brother-in-law that doesn't like anything sweet, but that's really unusual, I think. So we're going to be, last night, or yesterday, we said goodbye to Kimberly, our daughter, put her on a flight back to Miami and other parts of the country. And it was really special having her here. I just wanted to tell you that for her, she's been through kind of a spiritual journey, you know, how often young people do. They train up a child in the way that they should go, and when they're old, they won't depart from it. And sometimes we wonder about that promise when we see our children going off into other ways of doing things and ways of believing and not believing or whatever. You know, we just, our hearts ache, don't they? How many of you have children that you're praying for? Oh, all of us. I mean, who doesn't pray for your children? Because we know that the perils out there are so many, and as parents, you relate to that even more. And so it was a really special thing to have her come. She came to the first time that we came to the Caribbean, which was in Barbados, about 15 years ago. And she was just still a teenager at that time. And so that was a really, no, wait a minute. No, she actually was married by then, but young, you know, still. And so then busy life, mother, and so on, and various things in her life. And we saw her taking steps that worried us away from the way that she had been trained. But in recent years, I'm sure, I know that God hears and answers mother's prayers. And so she still has, don't we all, you know, more progress to make in the life that God has given us. And I thought about that when I also heard that there was a man here that we met in St. Lucia, at our first class at the Pastoral Center, and he was going to have his leg amputated the next day because of diabetes. And he came because his wife was one of the women that had been at a women's retreat. It was the Catholic Retreat Center. And she saw our doctor there getting ready for the class and got into conversation with him, and he told her what we were doing, and she said, my husband is going to have his leg amputated tomorrow from diabetes. And maybe you've heard this story. Jim probably told it to you. And Jim asked him some questions, and anyway, he came and his leg healed, and he, for years, was able to do his job. But we learned just at this class, at this time, that he did go back to his old ways of doing things and eventually died of his diabetes. And you know, that's the one really disappointing thing, isn't it? And as I was thinking about that last night, and then thinking about our daughter, and thinking about all the prayers, and thinking about my own life, and I just was again struck with how weak and erring we are as human beings. We just all need Jesus, don't we? Yes. We just need him. We can't do this of our own selves. And I just want to appeal to you. You know, we all are, the spirit is willing, but the flesh is weak. But with Jesus, we can do all things through Christ who strengthens us. And so I want to encourage all of us, including myself, because I'm not a wonderful example either. It's easy for me because my husband and the classes we do, and you know, I mean, I've learned this. My parents, his parents were all into healthful eating. We had every advantage. And so, you know, I'm very thankful for that. But I just want to encourage all of you, let's go home and every, you know, moment by moment, seek Jesus for help. Seek his victory in our lives, because we want to make this work. And how many of you, I already asked you how many of you were praying for your children. And before I go into this demo and pass those out, let's just bow our heads and let's pray for our children, shall we? And I want to invite you to pray in your heart for Kimberly. I just long for her, and for your prayers for her too, and I'm going to pray for your children. Heavenly Father, we as parents want to lift up our children just now, wherever they are, and you've said that if just two of you would agree on earth as touching anything that they would ask, it will be done of my Father which is in heaven. For where two or three are gathered together in my name, there am I in the midst of them. And you care about our health. You've said through your servant that you wish above all things that we would prosper and be in health. And so this is what you want for us, and we're just going to keep asking you for help at every step, and then we know that you will give it to us. So thank you, Father, and bless our children, and please bring them to the place that they need to be in order for your Spirit to work mightily to bring them to a full knowledge of you and of your ways of doing things. Thank you, Father, in Jesus' name, amen. Amen. Okay. So I just had to work that in, and I thought after we start the demos and after we start passing things out, things become kind of, it's hard for me to focus on you. So I'm going to, first of all, because last night we demonstrated the pie, the pudding, now I'm just going to demonstrate the cookies. And you know what I need is a place to plug this in. Do any of, I thought they were going to maybe work on that while I was upstairs, but I don't see that anything has been done. We need an extension cord that has this kind of plug. Do we have a 220 extension cord? If not, I'll have to demonstrate this in the back of the room, and you're going to have to all turn around, I guess. Is there? Oh, there's one over there. Okay, that's what we'll do. But first of all, I'll just start to tell you what I'm going to do. This is the peanut butter cookie recipe, and I usually do this in a food processor. But I didn't bring a food processor, and maybe it's just as well I didn't, because how many of you have a food processor? Several of you do, but not everybody. And so, you know, I didn't bring one, and sometimes I'll do it in my Vitamix, which is a nice, powerful blender. So I did 2 batches of them this morning in here, but it was kind of overworking the blending, and they were clumping up. And I finally decided I'm going to try the small blender that I have where we're staying. I meant to bring it, but this is one that they have here. And it's just the same though. So what I did was I put just a half recipe in here. One recipe is 2 cups of dry roasted peanuts. So I just put 1 cup in there, in the blender, and then you put in 1 cup of flour or oatmeal. And so I usually use oatmeal, because anybody that, well, most people that are sensitive to gluten can use oatmeal. There's some people who can't even use the oatmeal because it has some contamination, I guess, of gluten. So there, I just put those 2 things in there, and I put the lid on, and then I'm going to take this back there and blend it. And when I did it in the smaller one, it didn't over-blend it. It just seemed like it went through real easily. So I was really pleased at that. All right, I guess I can do it right in there, right? So those of you who can see, now that was pretty fast. I'm really quite impressed with how well that worked. And what I did was I blended it until everything was fine crumbs. And there was a point at which it kind of stays on the sides. So I did like this. I put some pressure so that it wouldn't come loose while I was doing that. Just, you know, shook the thing a little bit while it was blending. And then it made it go down into the funnel and blended it up. Now I'm going to put it in my bowl. We're going to do it one more time. The other half of the recipe. Now, I just noticed what she's doing over here. I want you to see this. Can you bring that out front and show them?
Yeah, sure.
We're also going to give you a sample of our French fries, French bakes. So I use this non-stick sheet here, and it's just a wonderful use for it because otherwise they really stick. But with this sheet, it just comes really loose really easily. And look at them, they're just perfect. What I do is we cut them up into this size. These are just regular russet potatoes, but most potatoes work. Red potatoes, white potatoes, or any of them. And then I put them in a bowl. And then I add seasonings to them. Where did I put that? Oh, here they are. Usually, I just use salt and paprika. But Kimberly was helping me one time, and she started adding some garlic and onion and turmeric. And so I had several things back here that I sprinkled in. I sprinkled some garlic powder. This is the paprika. Onion powder. I even put some yeast flakes in there. And I don't think I did this, but this is chicken seasoning. Anyway, you can, flavor them up if you want. And I just toss it, put them on those sheets, put them in the oven at about, so if I'm in a hurry, I'll put it up at a higher temperature. But you have to watch them. They take about 20 to 30 minutes. And then the best way to eat these is to eat them hot out of the oven. They tend to get a little bit limp after they've been sitting a while. So I'm sorry, some of you might get some hot ones, some of you might get limp ones, but you'll get the idea. Let's get these out to them as soon as possible now, while I just finish up the cookies. Here's how it looks.
Can you mention to them if they're allergic to peanut? Because the cookie is peanut. It has peanut in it.
That what?
The cookie. Some people might be allergic to the peanut.
Yeah. Is there anyone here who is allergic to peanuts? Do we have anybody? We just, watch out for yourself if they are, and you don't have to eat the cookie. We wouldn't want you to have a peanut reaction. But I think everybody's okay. So then, this is where I usually have a half cup of honey. And I warm it in the microwave just a little bit so it's real runny, and pour it on there and mix it in. And that is the liquid for this. And it holds it together. Now, I forgot to bring my honey. I had just the right amount at home left to use for this demonstration. So we'll use sugar, which I have done at times. This is your brown sugar here. I'll put a half cup of that in here. And then we'll add amount of water that the honey would be. About a half cup. I guess this will work. Okay, I'm going to, I wish Jim was here. I don't know where he is, upstairs talking to somebody probably. Because he made all the I made the dough today, and then he formed them into cookies for me. And I gave him a math problem, I think, that kind of stimulated him to do this. And I asked him to divide my dough up onto 4 cookie sheets, and the amount of dough that I had. And it was actually 3 times the recipe, and to put it onto 4 cookie sheets. And I'll show you how he did it. He was more precise. I'll show you how he did it. You kind of cut them up into, cut 8 pieces and each 1/8 into 3. So that makes 24. So he had 4 pans with 24 on each pan. So that gave us 100 cookies, which is about how many people were here last night. So how were your French fries? Good. French bakes, yeah. I'm sorry we didn't have anything to dip them in, but I thought if I put some other kind of dressing on the plate, it wouldn't mix well with our pudding. Good, thank you. And now the cookies, I have 24 balls on this cookie sheet. And I'm using my liners again. I just use these for everything. And then I'm going to get another one of those liners. This is what Jim did, and put it on the top of that. And flatten them. Little boy. He's strong. He's heavier than I am. Then you take a fork. Oops. Where's my fork? You use a plastic fork for this. A metal fork sticks. After about 2 or 3 cookies, it starts to stick, but the plastic doesn't. I learned that by accident one time when I was doing this for a class, and I forgot my fork, and someone handed me a plastic fork to use, and I've been doing that ever since. Whoops. So I won't take more time in front of everybody doing this, but I just want you to see, and usually I do it with, I put 12 on a tray. But, so you just got a half a cookie, but it looked like a whole cookie. But for our samples, we did it that way. So, you know, I really like this dough. You can use this as a roll-out dough and make cutouts. Children, my grandchildren used to love to, you know, help me make cookies and this recipe. But you can vary this with other nuts. You don't have to just use peanuts. You can use walnuts. Walnuts and coconut together make a really nice, 1 cup of each. And then the flour or oatmeal. So, you know, whatever you have, you can just really make all kinds of fun cookies with this idea. And this is also the same idea that I use for making pie crust. I whiz in the blender some oatmeal and actually, well, yeah, oatmeal, and I used to use Brazil nuts because they're high in fat, or walnuts. Because pie crust needs, you know, Crisco to make it real tender. And my mother-in-law always told me, when she taught me how to make pie crust, follow the recipe on the Crisco can, and then add an extra heaping tablespoon of Crisco to it to make it really tender and good. But then we, you know, she and I both got, so we didn't do that anymore, and started using other ideas and went through all sorts of things, and some kind of bad pie crust for years where if you don't have enough fat in them, they're very hard to, you know, they won't be tender. So I think for a pie crust, you just got to get a nice high-fat nut. Or my latest thing now is almond flour, because that's come into the stores, and it's already ground up. And I'll put equal parts of almond flour and quick oatmeal. And you don't even have to do any grinding. You can just put half and half almond flour and quick oatmeal in your bowl. I use 1.5 cups of each for a double crust pie, and then a 1/4 cup of coconut milk and a little salt. And you can make a really nice pie crust out of that. And that recipe is in your handout. So I guess you can find almond flour here in the stores if you want. But another thing you can do, and this is what I did for the little one that I sprinkled on top of your pudding, I used this coconut milk powder. I used a package of this and 1.5 cups of and 1.5 cups of oatmeal and a few almond slivers. But I think you could just use this half and half with the oatmeal if you. I haven't played with this enough yet. But there's another recipe in the book that uses just coconut and oatmeal, half and half, and you blend that together in the food processor. Dry coconut. So, you know, you got the idea in your head. Go home and, you know, God will help you. He helped me. The very fact of this cookbook is just a miracle of God's doing in my life, I believe, because I've told other people, I didn't know how to cook when we first got married. But, you know, little by little, and God just taught me and other people, and I kept at it. And I thought that if a person knew how to bake bread, that would just be the ultimate. And now that one girl that was my neighbor that I looked up to because she knew how to make bread, I was at her house recently, and she was telling me that she just loves my cookbook. And I'm thinking, she's telling me that, you know, like this table's got switched or something. But anyway, God will help us. So I think that's all. We're ready, aren't we? Has everybody been served? And unless there's any questions, we'll just let you go home. Just a question. Pardon? Oh, where do you get it? You know what? Oh, we'll put that on the website. I wish Jim was here because he looked it up today. And there's a site that he found that is really good. But actually, Margaret here said that she would order it and have it in her store. So that will be one source, is Margaret's store. The other thing is just go online. That's what we did. And this is not the kind that you're holding there. Is that okay? That is the paper, parchment paper. And you can use that maybe twice, but this you can use over and over and over. And it's very nice. So I was hoping that Jim, but the site that we found had, I think, 10 of these, or 12 of them for $10. That's US. And then it had fewer, you could get just 6 of them for $5 or something like that. So you can find them. Very easy to find online. But Jim was going to put that on the handout, so maybe we'll have it on the email one that we send you. All right, thank you, and we'll see you up there if we don't see you here again one of these days, or come up and visit us in Washington. Okay, thank you. God bless you all.